meet, the junction forms there. So this is a scenario when the PN junction is formed. Immediately after PN junction, there is a formation of depletion region. So as you know, N, that is electrons are negative charge particles, uh,
Yes.
holes are positively charged particles. So there will be force of attraction in between holes and the electrons. The electrons and the holes are very
Yes.
close to the junction.
CMS. CSC. CSC.
Yourself,
SC क्या?
please mute
Yeah.
yourself. So the electrons and the holes which are very close to the junction, they actually recombine with each other and they form the ions. In N type, positive ions are created because electrons are called as a donors, and as the holes accept the electrons, so they create the negative ions. Remember, the ions are immobile in nature. Whatever place जहाँ पर वो होते हैं, they are stationary. So they acts as a barrier. They act as a register there. So further recombination of electrons and holes near to the junction, it is been stopped by this ions created in the depletion region. Now because of this, a further electron or hole का recombination नहीं होता. If we want to bias the PN junction, I mean यहाँ से अगर हमें current flow करवाना है, then we need to apply that amount of voltage कि ये barrier potential या फिर depletion region को cross कर सके. So remember, at this position, the current is zero. There is no current flowing through this PN junction because of this depletion region. As soon as we apply some external battery potential and that becomes greater than the potential of the depletion region, we can observe the current flowing through this PN junction. Otherwise, अगर हमने कम voltage apply किया depletion region के potential से कम, then current is zero. ये हमने देखा barrier potential. Now, forward and reverse biasing of PN junction, this we are going to see now. The PN junction forms the most basic semiconductor device, that is semiconductor diode. Remember, di means two and ODE stands for electrodes. So there are two electrodes, we can say positive and negative, which is called as a anode and cathode. Diode means two electrodes. Diode has two electrodes for two regions. One electrode is connected to one region, for example, P region, and another electrode is connected to other region, for example, N region. So here you can see the symbolic representation also. Current always flows from anode to the cathode. राइट साइड में मैंने वो फोटो भी डाला है जो आप प्रैक्टिकल में डायोड यूज करते हैं. द सिल्वर कलर रिंग इंडिकेट्स दैट इज अ कैथोड टर्मिनल. रिमेंबर, the opposite one will be the anode one. So current flows from positive p type anode to the negative side, that is n type cathode. When PN junction is formed, the depletion region is created, as you know, and the movement of electron and hole stops. So current flow through unbiased PN junction is zero because of the depletion region. Now to make the current flow through the PN junction, we need to bias the PN junction. As here we are having two electrodes, biasing can be done with the two types. Remember, biasing is a process of applying external DC voltage to the diode. So biasing means what? We are applying external DC supply to the diode so that there should be current flow through the device. So biasing can be two ways. One is a forward biasing and another one is a reverse reverse biasing. So forward biasing हम पहले देखेंगे. What is mean by forward biasing? With
Positive
reference.
terminal to connect to positive terminal
Okay.
forward.
Look at this diagram which is right in front of you. PPT number 7. Okay. This is called as a forward biasing. So यहाँ पर क्या किया है कि P region of the diode, that is anode, it is connected to positive terminal of the external DC source. DC source नीचे लिखा है forward biasing. battery terminal. So when P region, that is anode, is connected to positive terminal of the DC source and cathode is connected to the negative terminal of the DC source, then it is said to be in a forward bias state. The diode is said to be in a forward bias state. Now, what happens when the diode is in a forward bias? See, due to forward biasing, negative terminal of the external source connected to N region. Now the free electrons from N side, they are pushed towards P side because वो opposite side पे attract होते हैं. N is connected to negative terminal, P is connected to positive terminal. So there will be force of repulsion in between P region and the positive terminal of the battery and N region and negative terminal of the battery. So the electrons which are present in N region and the holes those are present in P region, they try to accumulate near the PN junction and वो क्रॉस करने की कोशिश करेंगे जैसे यहाँ पर एरो में दिखाया है inside this PPT. Look at the arrow direction. The holes from the P and the electrons from the N, they will try to cross the boundary, they will try to cross the PN junction and वो बैटरी के opposite side में attract होंगे. Free electrons from N side are pushed towards P side. Similarly, positive end of the supply will push the holes towards N side. When the supply voltage increases, more electrons and more holes starts traveling towards the junction. When the voltage, as we are here in a forward bias state, we can say voltage जो हमने apply किया है, that voltage is called as a forward voltage. Now, as the intensity or level or the value of forward voltage increases, the free electron in N side move towards the junction, okay, and the holes from this P side again come towards the junction. So they will cross the junction as the battery voltage increases. They will go in the opposite direction. Holes will come in the P region and they will get attracted towards the positive terminal of the battery. The holes from the P region will cross the PN junction, they will come in the N region and they will get attracted towards the negative side of the battery. And in this way, as there is flow of electrons and holes inside the respective regions, we can observe the current through the PN junction. Of course, when the external voltage crosses the barrier potential. Now, in this part, whatever voltage that we apply externally, that voltage is called as a forward voltage, and the current that we observe that is called as a forward current. So, forward current and forward voltage, this is related to forward bias. Now, as the forward voltage increases, the current also goes on increasing. At an initial stage, at a zero potential, there is no current, and as we go closer to the barrier potential for the silicon or germanium, little amount of current is observed. Now see, silicon and germanium, these are the two semiconductor materials. The barrier potential for silicon, it is zero point 0.7 and barrier potential for germanium, it is 0.3. Just wait a minute, let me start the recording. Have you started, anyone?
No, ma'am.
Recording is started, someone has
Yes,
started.
ma'am. Yes, ma'am.
Yes, ma'am, Hardik.
Yeah, okay, fine, good. Thank you. So silicon के लिए barrier potential is 0.7 and for germanium it is 0.3. So unless and until external voltage crosses this barrier potential, very small amount of current is there. और जैसे ही हमारा external voltage barrier potential को cross करेगा, then we can say large amount of current we can observe. In forward bias, the width of the depletion region goes on reducing because there is overlapping or the pa- uh, passage of electrons from N to P region, holes from P to N region. Because of this, there is reduction in the width of the depletion region. So you need to remember few points over here, that when the diode is forward biased, we can say the width of the depletion region is reduced. Okay, and as the current passes through uh, the semiconductor material, uh, as the current voltage increases, proportionally current increases, that means the resistance decreases. So in a forward bias, the resistance offered by the PN junction is very low. Ideally it should be zero, but वो zero कभी नहीं होता. Practically small amount of resistance is there. Okay, and after crossing the depletion region or barrier potential, as the voltage increases, forward voltage increases, forward current also increases. ठीक है, तो proportional increment हमें वो particular voltage barrier voltage cross करने के बाद ही मिलेगा. The voltage at which there is proportional increment in the current is observed, that voltage is called as a knee voltage or cut-in voltage. Okay, so this is about the forward bias. रिवर्स बायस में क्या होता है, बिल्कुल इसका उल्टा. In reverse bias, the P region of the diode is connected to negative terminal of the battery, and N region of the diode is connected to positive terminal of the battery. Because of this, the majority charge carriers from both the regions, they try to flow away from the junction. And because of this, the width of the depletion region increases. As you can see in this diagram, the P region is connected to negative terminal of the external battery, and N region is connected to positive terminal of the battery. So the electrons those are present in N region, they will flow away from the junction, they will be in a outward direction. यहाँ पर देखो green color से arrow से mark किया है. So free electrons are moving away from the junction towards the external battery, and holes also flowing away from the junction towards the external battery side. Because of this, there is very small amount of current, negligible current, uh, we can observe in a reverse bias. So in a reverse bias, we can say, uh, because of this type of connection, the width of the depletion region increases. The current, ideally, in a reverse bias state, the current should be equal to zero, but practically there is small amount of current we can see through the circuit. The small amount of current which flows when the diode is reverse bias, it is called as a reverse saturation current or leakage current. So this reverse saturation current or leakage current, this flows because of minority charge carriers. So you can see in this diagram also, in P-type, majority charge carriers are holes shown as a white color dot. But there are two electrons also shown as a brown color. So N side में भी electrons majority charge carriers है जो brown color से दिखाए हैं, but there are few holes also. So because of the minority charge carriers present at both the ends, a small amount of current is there in a reverse bias state. That current is called as a leakage current or reverse saturation current. ठीक है, so this amount of this current is very small in amount, so generally उसको हम neglect कर देते हैं, या फिर वो बहुत ही कम वैल्यू में होगा, like in micro ampere or less than that. So in a reverse bias, we need to remember few things here, that in a reverse bias, the width of the depletion region increases. The second point is the current that flows in a reverse bias, majority charge carrier की वजह से जो current flow होगा, that is zero almost. Small amount of current is there, that is because of minority charge carriers. This current is called as a reverse saturation current or leakage current. And the third thing that you need to remember here is that in reverse bias, as the current is almost zero, the resistance offered by the diode is very high. So infinite resistance ideally होना चाहिए, but practically infinity नहीं मिलता. Very high amount of resistance is observed. That means in mega ohm. ओके, तो रिवर्स बायस में रेजिस्टेंस ज्यादा होगा, करंट बहुत कम होगा, width of the depletion रीजन ज्यादा होगा एंड रिवर्स सैचुरेशन करंट होगा अगर कुछ करंट फ्लो हो रहा है तो ओके. So this diagram you need to remember, this one for reverse bias, this one for forward bias. ये एग्जाम में क्वेश्चन आएगा. Explain forward and reverse biasing concept and what happens to the width of the depletion region. तो वो पर्टिकुलर हमने अभी जो एक्सप्लेन किया वो आपको बताना है. ठीक है. दिस इज अबाउट द थ्योरी पार्ट जो मैंने अभी आपको एक्सप्लेन किया है. नाउ दिस इज अबाउट द वीआई कैरेक्टरिस्टिक्स ऑफ पीएन जंक्शन डायोड. यहाँ पर आपने जो प्रैक्टिकली नोट प्रैक्टिकल जर्नल में जो डायग्राम ड्रॉ किया था ना वो डायग्राम ड्रॉ किया तो भी चलेगा. दिस इज नथिंग बट द वीआई कैरेक्टरिस्टिक्स डायग्राम वी आर we can here draw. So VI characteristics के लिए हमें क्या चाहिए? वोल्टमीटर चाहिए, करंट मीटर चाहिए. So voltage is always observed in parallel and current is always observed in series. तो same diagram आप यहाँ पर copy कर सकते हो. Whatever in this PPT number 10 we are having forward bias characteristics. Same circuit diagram you need to draw. Positive terminal of the diode should be connected to positive side of the battery. वहां पर आप एक वोल्टमीटर अप्लाई करो जो वोल्टेज मेजर करेगा या फिर डायरेक्टली इनपुट वोल्टेज हम कंसीडर कर लेंगे. करंट मीटर चाहिए टू सी हाउ मच करंट इज देयर. ओके. एंड दिस इज फॉर द सर्किट अरेंजमेंट. on x-axis you can plot the voltage because voltage is a independent variable. तो हमेशा याद रखना ग्राफ ड्रॉ करते समय इंडिपेंडेंट वेरिएबल शुड बी ड्रॉन ऑन एक्स एक्सिस एंड जो डिपेंडेंट वेरिएबल है वो हम वाई एक्सिस पर ड्रॉ करते हैं. तो यहाँ पर हमारा डिपेंडेंट वेरिएबल है करंट दैट शुड बी ड्रॉन ऑन वाई एक्सिस. So as this is for forward characteristics, forward bias characteristics, x-axis defines forward voltage and y-axis defines forward current. As we have discussed earlier, starting from zero, very small amount of current is there. As soon as the battery voltage crosses the cut-in voltage or for knee voltage, we can see sudden increase in the current, a sharp curve. So remember this PN junction diode is a non-linear device. जैसे वोल्टेज इंक्रीज होता है वैसे करंट इंक्रीज नहीं होता, प्रोपोर्शनल इंक्रीमेंट नहीं है यहाँ पर. तो शुरुआत में कट इन वोल्टेज से पहले almost flat response we can get, almost the current is zero, and after crossing the cut-in or cut-in voltage or knee voltage, sudden increase in the current is there. So graph is almost vertical, very parallel to y-axis. Okay, so this is about the forward bias characteristics. So these are some conclusions from the forward bias that diode doesn't obey the Ohm's law because V is not proportional to the I. क्योंकि पहले वोल्टेज बढ़ाओ तो करंट नहीं होता, कट इन वोल्टेज नी वोल्टेज क्रॉस करने के बाद सडन इंक्रीज होता है. सो डायोड इट इज अ नॉन लीनियर डिवाइस वी कैन सी. एंड from the characteristics curve we can say that the diode starts conducting only when the external voltage overcomes the barrier potential. For example, if silicon diode is there, 0.7 voltage cross करने के बाद diode on state में चला जाएगा. It acts as a closed switch. And if it is germanium diode, 0.3 cross होने के बाद diode acts as a on switch. Otherwise, it will be zero. The voltage at which the current starts increasing rapidly is known as cut-in voltage or knee voltage. This is the important point. आपको ये oral में पूछ सकते हैं. What is cut-in voltage? What is knee voltage? तो जहां से डायोड कंडक्शन स्टार्ट करेगा, the voltage at which the voltage on x-axis, of course, this is related to the forward bias. So the forward voltage at which the diode starts conducting and it acts as a closed switch. The current is there through the diode. That voltage is called as a cut-in voltage or knee voltage of the diode. Next point is reverse bias characteristics. Reverse bias में हमने देखा कि हमें क्या करना है. Only we need to reverse the battery potential by keeping rest of the parameters as it is. Diode को ऐसे ही रखो. Then We can say whatever voltage we apply in a reverse bias, that voltage is called as a reverse voltage, indicated as VR. And whatever current that we observed through the uh, circuit, that current is called as a reverse current. You need to replace the milliammeter by microammeter here, because the current is very small in amount in microampere range, so we can go for the smaller reading. So यहाँ पर हमें microammeter चाहिए, and the current is called as the reverse current. So remember, whatever current that flows through the diode when it is in a reverse bias state, this current is called as a reverse saturation current or leakage current. This current, remember, is the current which is present because of minority charge carriers only. And this minority charge carrier current totally depends on the temperature. As the temperature increases, the reverse saturation current that flows because of minority charge carriers also increases. Okay, so ये जो करंट होता है वो एक्सटर्नल बैटरी वोल्टेज पर डिपेंड नहीं होता. This current depends on the temperature. This PPT is very important. Look at this. ये आपके प्रिंट निकाल के आपके रूम में इसको चिपका दो. This slide is very important. This gives a differentiation comparison in between the practical diode and the ideal diode. ये एग्जाम में आ सकता है. Compare practical diode and ideal diode. लेफ्ट साइड का जो ग्राफ है, that shows the characteristic graph for the practical diode, and right side का जो graph है, that is for the ideal diode. Okay, we have done the practical based on this. Left side का graph पहले देखो. First quadrant, forward voltage on x-axis, forward current on y-axis. This current should be in milliampere range. Start with 0. Small amount of current is there before knee voltage. Knee voltage यहाँ पर indicate किया है. This is 0.3 for germanium, 0.7 for silicon. As soon as forward voltage crosses this knee voltage, we can say diode starts conducting. In a forward bias, we can have the conduction after crossing the knee voltage. Look at the quadrant number 3, where on x-axis we have reverse voltage and on y-axis we have reverse current. यहाँ पर आपको एक थोड़ा सा चेंज करना है. इंस्टेड ऑफ मिली एम्पियर यहाँ पर माइक्रो एम्पियर आपका स्केल रहेगा. So in a reverse bias, very small amount of current is there. In a reverse bias, we are going to see a breakdown phenomenon later on. Time being, just इतना याद रखो कि in a reverse bias, the current is very small in amount. That current is called as a leakage current or reverse saturation current. Now, after this, as we go on increasing the reverse voltage, a phenomenon occurs which is called as a breakdown phenomenon. Now we need to avoid this breakdown state, because once the diode goes in a breakdown state, it goes in a, I mean, it burns out because of excess heat. So ये breakdown हमें हमेशा avoid करना है, because recovery is not possible. The diode burns out, it gets damaged, and वो पूरा खराब हो जाता है. So in a reverse bias, we will stop here. कि हमें ब्रेकडाउन से पहले ही उसको स्टॉप करना है. वी आर नॉट गोइंग टू अप्लाई हाई रिवर्स वोल्टेज कि वो उसका क्रिस्टल स्ट्रक्चर ही ब्रेकडाउन हो जाए. एंड व्हेन द डायोड ब्रेक्स डाउन, एक्चुअली सडन इंक्रीज इन द करंट इज ऑब्जर्व्ड इन अ रिवर्स डायरेक्शन. तो ब्रेकडाउन होने के बाद क्या होता है कि बिकॉज ऑफ द एक्सेस हीट एंड दिस टेम्परेचर, टोटल क्रिस्टल स्ट्रक्चर ही ब्रेकडाउन हो जाता है, एंड huge amount of current is there in a reverse direction. जैसे यहाँ पर दिखाया है, a sharp increase in the current in the reverse side. The voltage at which this sharp increase in the current is observed in the reverse direction, that voltage is called as a breakdown voltage. There are two types of breakdowns we are going to see: Zener breakdown and avalanche breakdown. इसके आगे का part वही है. So always remember, we need to avoid this breakdown state so as to keep our diode in a good condition. राइट हैंड साइड का आप ग्राफ देखिए, दिस इज फॉर द आइडियल डायोड. तो आइडियल डायोड का ग्राफ इट इज वेरी सिंपल, वेरी स्ट्रेट फॉरवर्ड. फॉरवर्ड बायसिंग में जैसे वोल्टेज हम जीरो क्रॉस करते हैं, सडन इंक्रीज इन द करंट इज देयर. दैट मीन्स in a forward biasing, the diode starts conducting immediately after crossing the zero. That means the resistance for the ideal diode in a forward bias state is zero. Resistance of the diode, ideal diode, in a reverse bias state, it is infinite. तो जब भी आप कंपैरिजन करोगे in between practical diode and ideal diode, you need to show this graphs also. प्रैक्टिकल डायोड का ऐसा ग्राफ है, आइडियल डायोड का ऐसा ग्राफ है. देन we can say that when the diode is forward biased, it acts like a closed switch and it permits the current to flow. The resistance of the diode when it is forward biased, ideally it should be zero and practically it should be very small. In a reverse bias state, ideally the resistance should be infinite, practically it should be very high. In a reverse bias state, some reverse saturation current is observed, that is because of leakage current. Is this point clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now we are going to see the breakdown phenomena. Okay. Now, reverse saturation current that flows to the reverse bias diode depends on the temperature. So, जो leakage current होता है, that always depends on the temperature. The breakdown in a reverse bias diode can take place due to two effects. First is avalanche effect, that is related to avalanche breakdown, and second one is Zener effect, that is called as a Zener breakdown. Now PN junction allows very small current to flow when it is in a reverse bias state. This current is due to the movement of minority carriers. This current is independent of applied voltage, that is reverse voltage. If reverse voltage is too high, current through PN junction increases very rapidly, very sharply. The voltage at which this phenomenon occurs is called as a breakdown voltage. Now at this voltage, the crystal structure totally breaks down. This condition should be avoided in the practical lab and the diode may get damaged due to the overheating. So this is about the breakdown. Now we are going to see what is mean by avalanche breakdown and what is mean by Zener breakdown. First see what is avalanche breakdown. दोनों ब्रेकडाउन ही है, दोनों रिवर्स बायस में ही होते हैं, दोनों में शार्प इंक्रीज होगा करंट से, दोनों में डायोड डैमेज ही होगा. So we need to avoid this. So first see what is mean by avalanche breakdown. दोनों का मतलब मीनिंग somewhat it is similar, but एक थोड़ा सा पहले होता है, दूसरा ब्रेकडाउन थोड़ा सा बाद में होता है. So see what is avalanche breakdown. In avalanche breakdown, the increased electric field causes increase in the velocity of minority charge carriers. That means whatever voltage we have applied, reverse voltage, वो reverse voltage ज़्यादा increase होने की वजह से वो increase करेगा velocity of, that is movement of minority charge carriers. These are present inside the P and N region. Now this high energy carriers, that is minority carriers, breaks covalent bonds and they generate more carriers. As these minority charge carriers get external energy so that they can move from one place to the other and उनको ज़्यादा acceleration मिलने की वजह से they break some covalent bond when they move from one place to the other and they create the more carriers, वो कुछ कोवेलेंट बॉन्ड ब्रेक करेंगे और नए कैरियर्स जनरेट करेंगे. Again, these newly generated carriers are going to be accelerated, they are going to be moved, they going to be run by the electric field. They again break more covalent bonds during their travel inside the crystal structure. So नए जनरेट होंगे, वो भी हाई वेलोसिटी की वजह से एक्सेलरेट होंगे. अगेन दे ब्रेक कोवेलेंट बॉन्ड, अगेन द न्यूली carriers they will generate, again they will break covalent bonds, again new carriers generated. In this way a chain reaction continues, creating large number of carriers to generate. Now this gives rise to a high reverse current. This mechanism of breakdown is called as a avalanche breakdown. So avalanche breakdown happens because of acceleration or movement of minority charge carriers because of high reverse voltage. Reverse voltage ज़्यादा मिलने की वजह से carriers they move with high velocity, high speed inside the structure and they break the covalent bond. Covalent bond break करने के बाद some new carriers are generated, क्योंकि एक कोवेलेंट बॉन्ड ब्रेक हो गया तो दो इलेक्ट्रॉन जनरेट हो गए. अगेन दिस न्यूली इलेक्ट्रॉन्स विल गेट द एनर्जी, they will get the velocity, again they will move inside the structure and they break the covalent bond. And in this way a chain of reaction thus happens inside the structure. And because of that ये एक दूसरे का कोवेलेंट बॉन्ड ब्रेक करेंगे और नए कैरियर्स जनरेट करेंगे. And because of this the huge number of free electrons are created, are generated, and this causes a high reverse current through the structure. This breakdown, this phenomenon, when the crystal structure breaks down is called as a avalanche breakdown. Next type, it is a Zener breakdown. Again, this is very similar to the avalanche one. Zener breakdown, this happens when the reverse voltage is increased. The electric field at the junction also increases. High electric field causes covalent bonds to break and thus large number of carriers are generated. This causes a large current to flow. This mechanism of breakdown is called as a Zener breakdown. Okay, so this is very similar to the avalanche one, but Zener breakdown takes place somewhat at the initial stage and उसके बाद avalanche breakdown होता है. Okay, so this is about uh, the Zener and avalanche breakdown. Okay, now we are going to see the next topic, that is uh, rectifier. Is this point clear? Any doubt here? Any doubt?
Ma'am, avalanche breakdown.
Wait a minute. Avalanche breakdown, this causes because of increased electric field that increases the velocity of uh, minority charge carriers. When these minority charge carriers uh, move or accelerate through the structure, they break some covalent bonds, and after breaking the covalent bonds, new carriers are generated. Again, these newly generated carriers gets a sufficient energy to break again more covalent bonds, and in this way a chain of reaction is created, and large number of free electrons are generated that gives rise to the high reverse current. This uh, breakdown, it is called as a avalanche breakdown. Later, is my screen visible to you all?
No, ma'am. No, ma'am.
No, ma'am.
Just a minute. I'm trying because I'm logged in through the desktop. No problem here. I will continue with the next point, that is rectifier. तो तब तक आप
हेलो मैम। हेलो
yes,
मैम। एवलेंस ब्रेकडाउन या जीनर ब्रेकडाउन में से दोनों में डिप्लेशन सबसे ज्यादा किस में होता है?
क्या
मैम, एवलेंस ब्रेकडाउन या जीनर ब्रेकडाउन में दोनों में डिप्लेशन सबसे ज्यादा किस में होता है?
डिप्लीशन मतलब
डिप्लेशन होता है ना, डिप्लेशन वाइट्स।
दिस इज अ टाइप ऑफ ब्रेकडाउन। सो पहले जीनर ब्रेकडाउन होगा, डिप्लीशन रीजन दोनों में ज्यादा ही होगा। और दिस इज अ टाइप ऑफ ब्रेकडाउन।
मैम दोनों में लगभग सेम होगा।
Depletion region, this is related to the PN junction and this is a breakdown phenomenon. Actually, this is a concept, reverse bias way.
ओके मैम।
My screen is written. I'm pasting the attendance link for today's lecture. Timing ये आप feel करो. Uh, yes. Uh, please check your chat box. Please check your chat box and reply me whether you are getting this link or not. Hello.
Yes, ma'am.
Yes, ma'am.
We got it.
Yes,
Oh,
ma'am.
yeah. You can mark your attendance. I will see कि मेरे screen share होती है तब तक. Okay. I think it is visible now. Okay. I will give you 2 minutes to mark your attendance. Attendance mark करो पहले and then we'll start with the next point. Shall I start? Have you done with your attendance?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Uh, so after the diode and the characteristics and all that, we are going to see the second part of this unit number 2, that is applications of the diode. Second unit was about, I mean, second unit is about diode and its applications. So first part में हमने diode देखा, उसके characteristics देखे. Now in the second part we are going to see the applications of semiconductor diode. One of the most important widely used application of semiconductor diode is rectifier. So we are going to see how the diode can be used as a rectifier to get the desired result. We have done two practicals based on the rectifier. So can anyone please tell me what is the meaning of word rectifier?
Ma'am, it convert DC into AC. AC into DC.
AC to DC या DC to AC?
मैम DC
AC to
मैम
DC.
AC हाँ DC में मैम
AC to
कन्वर्ट
DC.
करता है AC को DC में.
Yes. Rectifier is a process of conversion of AC signal into equivalent DC signal. Okay. So how
Yes, ma'am.
specification is faithfully done, that uh, based on this we are having different types of rectifiers. Rectifiers are broadly classified into two types. One is half wave rectifier and the another one is a full wave rectifier. In full wave rectifier again we can have two types. Full wave rectifier by using center tap transformer and bridge rectifier. One by one we are going to see all the three rectifiers. Now look at this PPT. First type of rectifier that we are going to see is a half wave rectifier. The circuit diagram is right in front of you. As I said during this lab work, just a minute. Uh, the first component that is very important in the rectifier is a transformer. So transformer का हम ज़्यादा डिटेल में नहीं जाएंगे. The transformer that required for the rectifier practically in the labs is the step down transformer. Whatever AC input it is given to the primary winding of the transformer, that AC voltage need to be stepped down to certain amount at the secondary winding. So as shown here in the figure, at the left hand side, leftmost two terminals are the terminals of the transformer. They are directly connected to the AC main supply 230 volt and 50 hertz. 230 volts is the voltage of the AC main supply in India and 50 hertz is the frequency of that signal. हर एक कंट्री का उनके स्पेसिफिकेशन के हिसाब से अलग होता है. हमारे कंट्री का 230 वोल्ट 50 हर्ट्ज है. The function of the transformer is only limited for our practical purpose is to step down the voltage that is obtained at the primary windings. 230 वोल्ट सप्लाई का 10 वोल्ट में अगर हमें कन्वर्जन करना है तो ये स्टेप डाउन ट्रांसफार्मर हमें करवा के देता है. The another important use of having the transformer at the initial stage is it provides the isolation from the power line. That means power line हमारा directly हम diode power line को connect नहीं करते. In between that the power line and the diode, our main device, the transformer acts as an isolator. So it avoids the risk of electric shock. ठीक है, वो स्टेप डाउन होता है वोल्टेज, सो इतना ज्यादा वोल्टेज नहीं होता, एसी सिग्नल सेकेंडरी साइड में नहीं आता, so it avoids actually the risk of the shock. Remember the transformer, it is only used to step down the voltage. Whatever shape of the signal is there at the primary winding, that shape will be retained as it is. साइनसाइडल सिग्नल हम एसी इनपुट को ऑब्जर्व कर रहे हैं, तो साइन वेव सिग्नल ही हमारे ट्रांसफार्मर की सेकेंडरी साइड में आएगा. ओके, यहाँ पर कोई कन्वर्जन नहीं होता. कन्वर्जन इज डन बाय द डायोड एंड रेस्ट ऑफ द सर्किट. Transformer, it is only used for the step down purpose, and it is used to isolate from the power line so as to avoid the risk of the electric shock. Now we are going to see the next component, that is diode. Look at the orientation of the diode. डायोड का एनोड जो है वो ट्रांसफार्मर सेकेंडरी वाइंडिंग के अपर टर्मिनल को कनेक्ट किया है, एंड कैथोड इज कनेक्टेड टू द one of the terminal of the load resistor, that is RL. The another terminal of R load resistor is connected to the ground along with the secondary winding of the transformer at the lower side. So this is very small compact circuit for the rectifier. Single diode is used in a half wave rectifier. As the name indicates, half wave rectifier is a rectifier circuit that provides half of the input signal at the output side. Input signal we can observe at the secondary windings of the transformer, and output signal we observe across load register. Look at the circuit diagram. यहाँ पर R के across, load register के across दो external terminal wires दिखाए हैं, जहाँ पर V out लिखा है. V out stands for output voltage. Below that, AC input waveform, it is drawn 0 voltage, ground level. Whatever positive signal is there, that goes above the ground level, indicated as plus Vmax. Whatever signal goes below the ground level, indicated as minus Vmax. So total amplitude or swing of the signal is from plus Vmax to the minus Vmax. So this is about the AC input waveform provided by the transformer to the diode circuit. Now we have just seen the functioning of the diode. Diode acts as a closed switch, acts as a on when it is forward biased, and it acts as an open switch or off when it is reverse biased. तो जब forward bias होगा वो conducting state में होगा, reverse bias में non conducting state में होगा. So once again we are going to see the rectifier operation for the positive half cycle and negative half cycle. The rectifier, actually this is a circuit, as some of you have said, it is used to convert the AC signal into equivalent DC signal. But as here we are talking about half wave rectifier, faithful rectification यहाँ पर नहीं होगा. That means whatever signal we apply AC at the input side, वो 100% DC में convert नहीं होता. Some amount of unwanted factors are there at the output side. That unwanted part present at the output, it is called as a ripple. So ripple is a component of AC signal that is coming from the input side at the output. At the output of rectifier, we always want a maximum DC signal to observe across the load register. लेकिन rectifier circuit alone is not sufficient to convert AC into DC form. Now we are going to see its working. Now let's see what happens for the diode when it is forward biased. Now we'll divide the complete sine wave into two parts, for positive half cycle first and negative half cycle next. Now during positive half cycle of the input voltage, that is 0 to pi, the upper terminal of the rectifier circuit will be positive and lower terminal will be negative. Now this polarity makes the diode to go in a forward bias state. Now in this case, the diode conducts and current flows through the load resistor. So in a forward bias state, diode offers very small resistance, that means high current. The voltage drop across diode is very small. It will be 0.7 volt for silicon and 0.3 volt for the germanium. Therefore, the voltage appearing across load register is practically the same as that of the transformer secondary voltage. So when forward bias is there for positive half cycle, diode acts as a closed switch. This is the first part. Now when the negative half cycle appears during negative half cycle of the input voltage, the polarities get reversed. Now the upper terminal will be negative and lower terminal will be positive. The diode is now said to be in a reverse bias state, that is non-conducting state. Practically no current flows through the diode when it is reverse bias. In a reverse bias, the diode offers very high resistance and acts as a open switch. So there is no voltage drop across load resistor. So in the reverse bias state, the voltage across load resistor is equal to 0 for the pi to 2 pi negative half cycle. Now to sum up this, when the input voltage is going through the load register will get positive half cycle, and when negative half cycle appears, the output voltage is 0. So diode will be conducting in on state for positive half cycle and in a non-conducting state when it is in a negative half cycle. So we can observe the output waveforms as shown here in the figure. 0 to pi diode on, pi to 2 pi diode is in a off state. So all this theory you can read from this next slides, what happens and positive and negative half cycle, ये पूरा डिटेल में यहाँ पर दिखा है. Now this PPT is very important. Analysis of half wave rectifier. Sine wave, the equation is given as Vm sin omega t. This is the input signal. Vm stands for maximum voltage. Sin omega t because this is a sinusoidal signal. 0 to pi positive half, pi to 2 pi negative half, 2 pi to 3 pi positive half of the next sine wave. So 0 to pi में डायोड इज ऑन, यहाँ पर आप लिख सकते हो 0 to pi डायोड ऑन, pi to 2 pi डायोड इज इन ऑफ स्टेट. Now we are going to do the analysis.
मैम
हम्म.
मैम जैसे फिगर में दिखाया है केवल पॉजिटिव हाफ साइकिल को दिखाया गया है हाफ वेव रेक्टिफायर में, कि उसको निगेटिव में नहीं केवल हो सकता है क्या अगर करंट फॉलो कराए तो?
अगर आपको नेगेटिव हाफ साइकिल चाहिए तो आप डायोड का ओरिएंटेशन चेंज करो, जैसे मैंने प्रैक्टिकल में बताया था. So if you reverse the direction of the diode inside the diagram, positive half cycle disappear हो जाएगा and diode will be in a forward bias state for the negative half cycle.
ओके मैम, ओके, थैंक यू.
ठीक है. Okay, now we are going to do the analysis part. ये analysis आपको एग्जाम में नहीं आएगा. You need to only remember the end equations. तो ये डेरिवेशन आपको करने की जरूरत नहीं है. सिर्फ ये एंड इक्वेशन जो है ना वो याद रखो. डेरिवेशन इसलिए दिए है कि आपको समझ में आना चाहिए वो इक्वेशन आए कैसे. So first we are going to find out the equation for average load current. Stands for RLDC. RLDC stands for I, that is current, L stands for load, and DC, this DC term, just a minute, DC term, this is related to the output. Remember, as we are dealing with a rectifier, that means AC जो सिग्नल होगा वो हमारा इनपुट सिग्नल होगा and DC जो सिग्नल होगा that will be our output signal. So जहाँ पर भी हमारा DC टर्म आता है ना, समझो वो आउटपुट से रिलेटेड है, और जहाँ पर भी हमारा AC टर्म आता है समझो वो हमारा इनपुट से रिलेटेड है. Now coming back to this ILDC, that is called as a load current. ठीक है. तो लोड करंट, लोड मतलब आउटपुट साइड से है और आउटपुट मतलब रेक्टिफायर ये डीसी हमें देगा. तो टू फाइंड आउट दैट वी हैव द इक्वेशन आई डीसी. एल को थोड़ा सा साइड में करो क्योंकि आई डीसी itself indicates that this is a current related to the load. So DC है मतलब आउटपुट साइड का ही होगा, आउटपुट साइड का मतलब लोड से रिलेटेड ही होगा. तो अननेसेसरीली एक ज्यादा वहां पर टर्म डालने की जरूरत नहीं. So IDC, we can find out IDC is equal to area under the curve over the cycle upon base. ठीक है, so area under the curve is 1 upon 2 pi. We are going to take the integration from 0 to pi because 0 to pi में हमारा diode on है. Will replace Vm by Im sin omega t integration with d omega t. इसको अभी सॉल्व करना है. इंटीग्रेशन ऑफ साइन इज माइनस कॉस. आई एम कांस्टेंट बाहर आ गया टर्म. देन इंटीग्रेट दिस कॉस with 0 to pi values and at the end cos pi is minus 1 and cos 0 is 1. उसको थोड़ा रीअरेंज करो टर्म, मैथमेटिक्स ट्रिग्नोमेट्री अप्लाई करो. एट द एंड वी गेट आई डी सी इज इक्वल टू आई एम बाय पाई. ठीक है, आई रिमेम्बर डेरिवेशन करने की जरूरत नहीं है. ओनली नीड टू रिमेम्बर IDC is equal to Im by pi. This is the equation for half wave rectifier. Okay, so IDC stands for what? Output current, output load current. So to calculate the output load current, we have the equation Im. Im stands for maximum current upon pi. Next thing is to find out output voltage. Now see how we can calculate Im by using Ohm's law. I is equal to V upon R, right? So Im is equal to Vm upon, now R is defined with the various factors here. For example, RL हो सकता है, that is load resistor value. Along with this, we need to consider RF also stands for forward resistance of the diode. Then RS, that is secondary winding resistance of the transformer, and RL. Vm stands for maximum peak voltage. Voltage, V stands for voltage, M stands for maximum. या फिर okay, maximum. So Im is equal to Vm upon RL is a maximum resistance. RF, this is a forward resistance of the diode, and RS stands for resistance of the secondary winding of the transformer. This is actually a detailed equation. Most of the times RS and RF को हम neglect करते हैं because the value of RL is too high as compared to the RF and RS. So generally we write Im is equal to Vm upon RL. Okay. So this is the Ohm's law equation. Im is equal to Vm upon RL. The next parameter is load voltage, VLDC. Directly last equation देखो, VDC is equal to Vm by pi. जैसे IDC is equal to Im by pi है, वैसे ही VDC is equal to Vm by pi होगा. Okay. डेरिवेशन ज्यादा देखने की जरूरत नहीं है. नेक्स्ट इज RMS लोड करंट. RMS stands for root mean square. Okay, so AC or RMS load current, the amount of AC present in the load current, we are going to find out with this equation. IRMS is equal to Im by 2. This is the equation for half wave rectifier. IRMS is equal to Im by 2. Im हम कैसे find out करेंगे? Im can be find out by the equation Vm upon RL. Okay, and once we find Im value, we can calculate IRMS. Root means square current, that is RMS load current. That is equal to Im by 2 for half wave rectifier. Next is RMS load voltage. VRMS is equal to M by 2. See, V voltage is equal to current into resistance by Ohm's law. So VRMS is equal to IRMS into RL. IRMS is Im by 2 into RL. So VRMS is equal to, you can rearrange the equation, Vm by 2, okay, in this way. The next point is very important, that is ripple factor. Okay. So we'll take ripple factor in the next class. I hope these points are clear to you.
Yes, ma'am.
ओके तो कल हमारा 1 बजे लेक्चर है. आई विल कंटिन्यू फ्रॉम दिस रिपल फैक्टर ऑफ हाफ वेव रेक्टिफायर. देन विल टुमारो will complete the full wave rectifier by center tap transformer and